Hello everyone, and then welcome to another tutorial video. Okay, so in this video we'll be trying to go through the concept of what integration and how to simplify or how to evaluate integration. So this will be just an introduction to what integration, the concept of integration. Without further much ado, let's dive right into this tutorial video. In case you are new here, kindly subscribe to the channel, turn on your post notifications so that you don't miss out on future videos. Like the video so that it gets pushed to other students like you who are in need of this video. Okay, and then if you have any questions, just leave them in the comment section, then reply to them as soon as possible. So we know that the concept of integration is all about, so we know that differentiation is something like subtraction, but integration is what? Addition. Okay, keep that in mind. Differentiation is what? Subtraction. Integration is all about addition. Okay, so we have what? Let's say you are integrating something like trying to integrate x of n, x exponent n. So x exponent n is something like x exponent what? 5, okay, x exponent 7, x exponent what? 3. So it could be raised to the power any value, okay, or any number. Okay, so once you come across any question with what? Any form of this or has its form in this way, all you have to do is just use the what? Principle of what? Exponential what? Integration to integrate the expression. So let's say we have what? An example. Okay, so we have the integral of x dx. Okay, so how do you do this? So let me give you the general rule. Okay, so once you come across any what integration raised to the power or any expression, let's say x raised to the power a certain value n, okay, this is how you just use it's a simple method we use in finding the integral. So you just use this concept. You have 1 over what? N plus 1, okay, and then you keep what? The expression, and then you have what? N plus 1. So that's why from the beginning, and then you add your what? Constant. That's why from the beginning I stated that integration is all about addition, okay, and what differentiation is what? Subtraction. Once you know this concept, you are good to go. Once you understand that integration is what? Addition, and then differentiation is what? Subtraction, you are good to go. So let's take another example. So let's say we have what? X exponent 4, okay, dx. This will give us what? Just using this simple formula, okay, we have what? 1 over what? 5, and then we have f x exponent what? X, then we have what? Constant being added, okay, just this principle. Just add 1 to the exponent and then use that as what? The coefficient, but what? The inverse of the coefficient, okay. So when you talk about inverse, it's something like s exponent minus 1, which is the same as what? 1 over what? X, okay. So when you have x exponent minus 3, it's the same as what? 1 over what? S exponent what? 3, okay. That's how it works. So let's take another example. These are very simple and straightforward. Try to understand these concepts from the beginning so that you don't find yourself wanting. Okay, so we have another example. So let's say we have x exponent, let's say 7, okay, dx. So this will give us what? 1 over 8. Then x exponent 8, you add your constant, okay. These are very simple. Let's say we have what? 5x exponent what? 3, okay, dx. All you have to do is just take the integral. So from here you could notice that we have a constant. So whenever you have a constant, just separate the constant from the main expression, okay, something like this. Okay, so this will make it a bit simpler for you to solve. So we have something like 5 over what? 4 over here because of what? The exponents, which is 3, okay, and then we have x exponent what? 4, and then we have our what? Constant, okay. Let's look at something a bit complex, okay. So we have something like x cubed minus what? 5. Let's say x exponent 2. Let's say we have what? 7x minus what? 11. Okay, so from the beginning, in case I didn't state that, let me reiterate, okay. So whenever you come across a constant, whenever you are trying to integrate a constant, let's say a constant 2, okay, whenever you are trying to integrate a constant, you just add what? X, okay, because we are differentiating, we are integrating with respect to what? X, okay. So just add your x and then you add your constant. That's why initially I stated that integration is what? Addition. So in case this was let's say this was differentiation, okay, this would have been what? Differentiated to what? 0, okay. This would have been differentiated back to 0 because differentiation is all about subtraction. Okay, so let's proceed from there. Now let's proceed from here. So let's try integrate this. So from here we have what? 1 over 4 x exponent 4, okay, and then we have what? Minus what? 5 over what? 3. That's from here, x exponent 3, and then we have what? Plus what? 7 over 2 x exponent 2. We are just adding, okay. Just concentrate on the what? Exponent on what? Of the x, okay, and just proceed from there. And then we got to know that whenever you integrate a constant, we end up with what? Adding the what? X, okay. That's when we are integrating respect to x. It could be integrating respect to u, y, z, it doesn't matter, provided you know what we are integrating respect to, okay. After that, you just add your c. Okay, this is very, very simple. This is just an introduction to what? Integration. So once we know this, we can further, go into what? The concept of what? Integration. So let's first look at what? Another form of what? Integration, okay, where it has to do with what? Line. Okay, so let's say you are integrating any expression. You are integrating any expression in this form, okay. So let's say you have 1 on x. So 1 on x, note that 1 on x is the same as x exponent minus 1. So how do you integrate this, okay? So in order to do that, you just introduce your line, okay. So we have what? Let's say you are integrating 1 on x, the x. All you have to do is just introduce your what? Line. So you have what? Line of what? The absolute value of x, and then you add your constants. You see how simple this is? Very, very simple. So this is how you try integrate any form of expression like this, okay, provided the expression is in this format, okay. So provided this was maybe differentiation, okay, you would have subtracted 1, you would have gotten what? Minus 2, okay. But this is what? Integration. So this is how we do the we try integrate. So let's take another example. So let's say we have maybe 1, okay, 1 on, let's say 5x plus 6, okay, and then we are trying to integrate this expression. So keep this in mind. Concentrate on what? The x, and then the expression, okay, the format of the expression. So this will give us what? 1 over what? X, okay, and then you have the len absolute value of what? The denominator. You'll be applying this concept in what? Definite integral in just a minute, okay. That's why I'm trying to introduce this example before I go into that. So we have what? 1 over x, okay, len of what? 5x plus 6, okay, is the absolute, okay. Keep that in mind. This is an absolute. So when it comes to absolute, we don't have anything like a negative answer, okay. For absolutes, you always end up with what? Positive answers. So this is how you integrate with respect to something like a fraction of what? 1 over another expression, okay. From here you can notice that we have what? 1 over x, okay, that's 1 over an expression, and then from here we have what? 1 over what? 5x plus 6. That's also an expression of what? 1 over another expression, okay. So let's dive right into what? Definite integrals. So let's look at what? Definite integrals. Okay, so for definite integrals, okay, so you try to introduce what? Limits, okay. So for the normal integration, you wouldn't usually have what? Limits. So for definite integrals, that's where we have limits. And then for indefinite, it's just the quite opposite, okay. So let's see how we go about what? Definite integral. So for definite integrals, let me give you an example. So you'll be given what? The limit. So let's say the limit from maybe n to y, okay, and then we have what? X, and we have what? Dx. This is just an example, okay, to give you a fair idea of how definite integrals usually look like, okay. So let's take an example. Let's take an example. So let's say we have what? Let's take a simple example. So let's say we have what? 2, 1, and then we are taking what? The integral of what? Let's say x, okay, then the x. So all you have to do is just take the integral of this x. After that, you substitute the expression with what? The limit. So we have something like what? 1 over 2, okay, x plus what? C, and then you you introduce your limits. Okay, so your limit is from what, 2 to 1. So for now, let me state this: for definite integrals, you don't even have to introduce your constant. Okay, for definite integrals, you don't usually have to introduce your constant, so you could just leave your answer in this format and then you proceed from there. So you have 1/2 x, okay, and then you take your limits. Now this is how you take your limit. You take the positive side and the negative side. So you have what? You have 1 over what? 2, and then 2 over here. Okay, that's the positive side, and then we take the negative side. Okay, and then that's where we have what? 1 over 2, and then we have what? The second limit, which is what? 1. Okay, so you can just simplify this further. From here you have what? Just 1, because this will give us what? 1, and then we have what? Minus what? This will give us what? 1 over 2. So you could just simplify this further to whatever answer you get over here. That's not the main concept over here. I want to introduce you to more complex expressions. Okay, so let's take another example. So let's say we have what? Okay, so let's look at this example. Okay, so you can notice that this is what? A definite integral type of question. Okay, it looks a bit complicated, but it's not. Once you understand the concept, you are just good to go. So let's try solve this question. So we have what? Try solving this. First, the first things first is to try to expand this expression to make it as simple as possible. Okay, so let's do that. So we have what? The integral from 2 to 1. Let's expand the numerator. From the numerator, we have what? We are just multiplying x across this second expression. After that, we do that for 1 across this expression. So we have what? X cubed, okay, minus 2x squared, and then we have what? Plus 2x. That's from here. And then let's look at the second one. So we are multiplying 1 across the entire of this expression. So we have what? Plus x squared minus what? 2x, and then plus what? 2. And then you divide that by what? The denominator, which is x squared, and then you introduce your what? Dx. Now from here you could notice that some of these expressions could just cancel out. So we have 2 on 1. So we have what? We have x cubed over here minus 2, and then what? Positive minus 2x plus what? X squared. That will give us what? Just negative x squared, and then we have what? This will cancel that, and then it will be remaining with what? Positive 2. You divide that by what? X exponent 2. You have what? Dx. Okay, you could notice that you are just trying to break this expression down. So from here you could further simplify this. So we have what? When you divide x squared across this expression, so we have what? You end up with what? X minus what? 1 plus 2. Okay, and then you divide it by what? X squared, because when you divide it by that, we only x. This will give us what? Negative 1, and then this will give us what? 2 on dx, 2 on x squared, and then we have what? Dx. Now we can just simplify this by using our general form of what? Definite integral. So we have what? Let's see. So let's integrate the whole of this expression. So we have what? 1 over 2 x squared. That's from here, and then from here we have what? X, and then from here you can notice that this is what? 2 over what? X squared. This is the same as what? 2x exponent what? Minus 2. Okay, so when you integrate this, you end up with what? Minus 2 on what? X. That's very, very simple. And then you introduce your what? Your limits. Okay, so we have 2 to 1. Let's insert our limits. Okay, so we have what? 1 over 2. You have 2 what? Squared minus what? 2, and then minus what? 2 over 2. Okay, and then you subtract that from what? We have 1 over 2. We have 1. So we are using 1 now. And we have what? 1 minus what? 2 on 1. So when you simplify this further, you end up with what? When you can just point this on your calculator straight ahead. Okay, just point this on your calculator. There's no need to do anything further. So just use your calculator to find a final answer for this, and then you end up with what? 3 on what? 2. Okay, around this figure you end up with 3 on 2. That's approximately maybe 1.5. Okay, right. So let's look at another example. Hope this example was very, very simple and what straightforward. Okay, we just need your understanding, okay, because these ones will sound a bit confusing. Okay, so let's look at how you could solve this one. Now from here you can notice that this is a bit different from what we initially solved. Okay, so this could be just further simplified into what, something like x minus 1, okay, and then we multiply this by what, 1 over what, x squared minus 2x plus what, 2, and then we have dx. Okay, just picture this expression in this format, okay, so that whatever I'm about to do will sound a bit simpler and straightforward. Okay, simpler and straightforward. Picture this expression in this format, okay, so that everything sounds simpler and straightforward. Now let's proceed from here. So when you take the first, you have to introduce a certain form of what, integration and what, differentiation. Okay, so that's what we'll be implementing over here. So first, let's try solve this question. So from here we have what, from here, from the denominator, okay, from the denominator we have 2x minus what, 2. Okay, that's why initially I stated that we will be implementing differentiation and what, integration when it comes to these kind of questions. Okay, so first differentiate the denominator, okay, and then you divide that by what, the denominator itself. So we have what, x squared what minus 2x, okay, then you have what, plus 2, then you maintain your what, dx. Now you go further to simplify. So we have what, so after taking the differential of the denominator, and then we had what, 2x minus 2. Now let's try find what, the integral. Okay, let's find the integral of this expression. Okay, so this expression has been divided into two. Let's say we have what, your u here and what, your v here. Okay, so first we took the differential of this, the v, only the v, okay, not the numerator, just the denominator, and then we had this, and then we kept what, the denominator. Now let's take what, the u into consideration. Okay, so let's integrate with respect to only x. Okay, and then you end up with what, 1 over what, 2. Okay, and then you take the ln of what. That's why initially I stated that we'll be implementing this approach. Okay, this approach. So we are just integrating with respect to something like 1 over x. Okay, so for 1 over x, notice that you integrate with respect to 1 over x, and then you end up with what, 1 over x ln of x. Okay, that's the same approach we'll be using over here, because this is something like 1 over what, x squared minus 2x plus 2. So we are just taking this into consideration, the denominator. Okay, and then we had what, 1 over 2, and then we keep what, the denominator, x squared minus 2x plus what, 2. And then this will be a general what, expression. You just introduce your limits like that. Okay, again, in case you didn't understand, let me just go back again. Now for this kind of expressions, okay, for these kind of expressions, picture this expression in this format. Okay, something like x minus 1 multiplied by what, 1 over x squared minus 2x plus 2, so that you'll picture it in the form of what, 1 over x. Okay, so this will be like the 1 over x squared minus 2x plus 2 will be in the form of 1 over x. Okay, that's why initially I stated that with respect to that integration format, we'll be implementing that in what, definite integrals. Now, so after doing that, just take the differential of this denominator. Okay, when you take the differential, you end up with this, and then you maintain what, the denominator like that, and then after that you just integrate. Okay, you just integrate the x. Okay, integrate this x, forget about this minus 1, integrate this x. Okay, and then you end up with what, 1 over 2. Because we are using what, this expression as what, reference, we just keep this expression. Okay, there's no need to introduce what, ln of maybe this x again. Okay, we are just using this expression as reference. That's why I initially stated that this might sound confusing, but we will solve another example so that you get to understand similar example. Okay, so let's proceed from there. So let's insert our limits. So from here we have what, 1 over 2, taking the limit of the absolute value of what, 2 squared minus what, 2 multiplied by 2, plus what 2, taking the absolute, okay, minus what 1 over 2 ln of what 1 squared minus what 2 times 1, okay, and then we have what positive 2, okay. So once you point this, the entire of this on your calculator, you can just use your calculator to find the answer. Once you point the whole of this, you subtract this from that, you end up with what 1 over 2, okay, ln of 2, okay, 1 over 2 ln of 2. So this will be your final answer. So I know this sounded confusing, so let's take another example so that you get to understand. So you could just go back to try to understand, because this is very simple and straightforward, okay. So let's take another example which is very similar, so that you get to appreciate the concept of what definite integral. So you'll be applying the same principle over here, okay, same principle. So first we take the differential of the denominator, okay. So let's first write it in that format, okay. So we have what x minus 1, okay, and then multiply that by what 1 over what 3x squared minus 2. So let's first take the differential of the what denominator, okay. So we have what this will give us what 6x, okay. So here you end up with what 6x, okay. Then you divide that by what 3x squared minus 2. So let me just bring the dx over here, okay. So after this, so we have what the x, just as I initially stated, all you need to do is just take what you just assume that this is okay. So let me rewrite that in this format so that it becomes simpler. Let me rewrite that over here so that this concept becomes simpler. So this is something like 6x, okay, multiplying 1 over what 3x squared minus 2x, okay. Picture it in this format, okay, so that it will be simpler. So from here you could also picture it in this format, okay. So it could be what, let me rewrite that, so that this would have been also what 2x minus 2 multiplying what 1 over x squared, okay, minus 2x plus 2, okay. So this you could just rewrite that in that format. So yes, you could just rewrite that in that format, and then from here we have what 1 over 6 ln of what this expression. So we have what 3x squared minus 2, that's the absolute, and then you introduce your limits, okay. Introduce your limits. That's why initially I stated that you just have to ignore this expression, okay, and then concentrate on what is given in the form of what the expression 1 over x, okay. So this expression is given in the form of what 1 over x, but this x is what our 3x squared minus 2, okay. This is very simple, very simple and straightforward. So after doing this, so after taking the differential of the denominator, you make that as what your numerator, and then you maintain your denominator. After that, you could just rewrite this in the form of what 6x multiplying 1 over 3x squared minus 2, and then you just take the fraction of what this expression, that's what 1 over 6, okay. So just like here we also did that, okay, 1 over 2 over here, okay, 1 over 2 over here. So you just take that and then you are good to go. So let's insert our limits. So we have what 1 over 6, okay, 1 over 6, then we take the limit ln of 2 squared minus 2, okay. Note that this is what absolute, then you subtract that from what 1 over 6, then ln of what 3, this 1 squared minus what 2, right. So that's what the absolute, okay. So when you simplify the entire of this expression, end up with what 1 over 6 ln of 10, okay, 1 over 6 ln of 10. So this brings us to the end of this tutorial video. I hope this video was helpful. In case you have any further questions, just let me know in the comment section, and then I'll rectify them as soon as possible. Thanks for staying with me till the end of the video, and then in the next video we'll be treating what substitution by integration. I will be giving you a simple trick where you could use to solve substitution of what integration. I'll see you in the next video. Have a lovely day.